name is Adarsh, and today I will be giving a short demo on how we can map offline problems that comes when anyone opens a new company versus how system design problems that a software engineer face by making their system design scalable, right? In terms of both HLD and LLD comes along, right? So that we can have a clear understanding of how we can map the software problems with the real world problems that happens, right? So to start with, a person named Sam wanted to open a company, right? So and for that he contacted a burger company which used to sell online burgers as well. So he thought of getting all the online orders from the burger shop, and correspondingly he hired a delivery executive as well, so which will deliver his order from the burger shop to the destination. Now this business started working off well because the burger shop eventually had increased in revenues, right, and orders were dropping in more. So the burger company was happy enough, right, and so was Sam. But there were multiple problems that came along the way and became a bottleneck in scaling this company, right? So we will be looking into each of the problems and how we would have solved in an offline use case as well as in a system design use case, right? So the first and the foremost problem was, since the orders were dropping more, there were a lot of pressure that was happening on Rahul because he was the person who was doing most of the job, right? So in order to solve this, Sam, being a smart manager, he offered more money to Rahul so that he works more efficiently, and henceforth asked him to increase his throughput in delivering the orders, right? So in order to compare it with the system problems, this particular solution can be compared to something what we call as vertical scaling, right, where we are spending more on the machines without without buying more machines, right? So this keeps the things very simple, as because it requires less maintenance, there's no code change that is required, and it also serves our purpose, right? So did like this helped the company a lot, and they were now able to deliver orders at a good speed. But do you think that this is still a scalable product, right? No. Why? Because there are a couple of problems that are there. First is we have one delivery person, right, and now the delivery person is working a lot, so he might fall sick, right? Now if the delivery person falls sick, it will actually close our business because we don't have any alternatives, right? So in this case, Rahul becomes a single point of failure for us, which we call as SPOF also in system design, right? In order to solve this problem, what Sam did was he hired more delivery executives, right, and he hired them on demand basis, so that whenever there is peak, he can ask them to deliver orders, and also he would save on money, right? So this was a smart move by Sam. And now if we compare it with our system design, this solution can be compared to something what we call as horizontal scaling, right, where we are buying more machines instead of investing in a single machine, right? So that our system becomes highly available, there is a less downtime, and also we can resize it according to the peak hours, right? So again, we can see that there is a clear one-to-one mapping between an offline use case and an online use case, what we solve for, right? Again, moving forward, this helped the company to scale further and cross its previous peak. Now there were a couple of more problems is still lying in the system. The next problem is, right, since he hired a more delivery executive, but did he hire smart? The answer is no. Why? Because he hired from a same zone or a same area that was near the burger shop. And what if there was a calamity, if there was some political thing going on in that road because of which the road is closed, he would have lost on all the delivery executives, and again he would have been left with no alternatives. In order to solve this problem, what he went back and did was he hired again different delivery executive, but this time he hired from different zones, right? So what it would help him with is, if any of the zones is blocked or due to any reasons, then he will not be able to be blocked on his business. He would be able to run his business, but on a smaller level. Now in order to map this, we can again think of our software system design, where we can map this particular problem with something what we call as distributed computing, right, where we distribute all the instances in different regions or availability zones, so that if any foreseen circumstances happen in that particular region, we do not block, or our website is not down for the same, right? Now things are going pretty good, right, but now the orders are peaking in more, so we can again think of a single point of failure that can happen in this system, right? And that single point of failure can be Sam itself. Why? Because Sam is the whole and soul who is receiving the orders from the burger shop, and then he is transmitting all the orders to the delivery person, right? And in order, like while Sam is doing so, he might make some mistakes due to which he would lose on customers. For example, in this instance, a person orders from a house near to the burger shop, but Sam gave the order to a delivery executive who was far away from the house, and hence the customer got angry. Instead, he would have given it to a person who was very closer to the house, right, and the shop as well. So this kind of smart work now has to be handled by Sam alone, right? Now he wanted to solve this problem again. So in order to solve this problem, he came up with the next solution, where he hired one more person. Now the job of this person was to handle all the distribution of orders. So now the job of Sam reduced to taking the orders from the burger shop and giving it to the executive. Now it was job of the executive to be smart enough and distribute the orders so that the delivery is on time, right? Now what can this be compared with, right? So in system design, this can be compared with a load balancer. Why? Because a load balancer is the entity that is responsible for distributing all the traffic that we are receiving, and this distribution is made on logical parameters like availability, the health of each of the instances, and it ensures that we keep a very less latency when we are giving our orders to different systems, right? So again, we can see some mapping how the offline and the online world works. Now so far we have come across and the system is set up and it is more or less resilient. Now coming to scaling up, right, where we want to acknowledge more use cases, right? So another use case came for Sam, like where another shops or different shops wanted to tie up with Sam. So now a pizza shop also wanted to tie up with his company and get his pizzas delivered by the delivery executives. The good part that worked for Sam was he never hired the delivery person telling them that they only need to sell burgers or they only need to deliver burgers. So the delivery persons were quite open to deliver anything that Sam used to give them, right? So this was indeed a smart move by Sam. Correspondingly, if we think the same in our system design, right, we should create our code uh, extensible enough, right, so that we do not need to go ahead and change our code for adhering to such use cases, right? So this also corresponds to strict solid principles, right, where we should code in such a manner where we should not allow any modification and still we are able to extend the code for different features that comes into play, right? So these were the few comparisons that we can see how a real world example and an online system design problem can be compared with, right? So in order to conclude with, we have talked about some of the parameters that we hear on day-to-day basis as a software engineers, right? So we talked about throughput, how a person can increase his way of doing work and increasing his efficiency, right? We talked about scaling, that how we can scale both vertically and horizontally. We talked about single point of failure in the systems and how we can mitigate them by actually creating a distributed system. We talked about load balancers, which would increase our availability and also decrease our latency. And we at last we talked about extensibility, where we should write the LLD code in such manner which is extensible for any further use cases that comes into picture. Thanks. So this was it from my side. Thank you. Until next time.